This video is the beginning of chapter 9 into section 911. This chapter is going to start off pretty easily. What we're looking at really is inequalities. I got some new software that will hopefully make this process easier, and I don't know how it is going to go, but essentially we're looking at something like this. We're going to start this chapter by... see if this does what I want it to. Oh, hey, all right. So we're going to start this chapter by doing things in one equation. One variable, which means essentially we're looking at the x-axis, right? We have a number line, and we're just going. That was not supposed to be that way. And we're gonna, just graph on the x-axis. We're not going to worry about the y-axis yet. That's going to come later in the chapter. I still don't think it might in some ways gets easier in two variables than it does in one. But when we do this, we need to really understand what it means to be on the number line. So if we see something like this, like what is the difference between an open circle and a closed circle? What does it mean when the arrow is pointing to the right? What does it mean when the arrow is pointing to the left? Those are the kinds of things that I'm guessing a lot of you know about already, but just from previous experience, I'm assuming some of us don't know. So I think it would be in our interest to kind of talk about those before we really start the chapter. And I think the math notes is a nice place to start with that. So bear with me here. I'm going to see if I can delete some of the stuff. I don't want that. I don't think I want my eraser either. Oh yeah, I'll be damned. It did work. Okay, again, still trying to get used to this, so I apologize for my ignorance. So long story short, when we look at this, these signs are really important. And again, the great Tyler Oliveira, YouTube sensation, and he and I had a conversation about these things, and he didn't understand that they were named. And there is a less than and there is a greater than sign, and it matters which side that they're on. For instance, if I wrote something like this, it wouldn't make sense because 10 is not less than 7. This is the less than sign. You'll see it looks like an L. So there we go. 7 is less than 10. Again, this says 10 is less than 7. That's false. It doesn't make sense to write it that way. If we wanted to write this, we would say 10 is greater than 7. We wouldn't write 7 is greater than 10 because that wouldn't make sense. So again, this is a real thing and this is a real thing, and these are the actual names of them. So this looks like an L, less than. I've had students in the past tell me that if you do this, it looks like a G, and I suppose that that's true, and that you can make a greater than sign out of that, but I think that's a bit of a stretch. So that is our greater than sign. Again, I think that's a little bit silly, but whatever. So we do have 7 is less than 10, and we do have 10 is greater than 7. The next thing is, how do we go ahead and make those points? What's the difference between an open and a closed circle? Well, the idea behind an open and a closed circle is this. If I say something is true, essentially what I'm doing is I'm putting a dot on it. So if you imagine a number line and I say, hey, look, x is equal to 1, I'm going to go here and I'm going to put a closed circle. So that means it's true at 1. And you'll notice, and again, this may not seem like it's true, but there's an infinity of open circles over here, an infinity of open circles over here that we don't actually see because they're not true, right? That's the whole point of not being true, is we don't really care, so we don't really need to denote it. So what happens is if something is equal to, we use a dark circle, and if it's not equal to, we use an open circle, but we don't really need to do too much with that. So what happens is this. We get in this situation where, let's say I want to say that x is greater than 2. Well, 2 is a boundary, and we're going to learn about that in terms of the vocabulary, but 2 is a boundary. Something happens at 2. So I'm going to go ahead and put that circle. The question is to x equal to 2? Can it be 2? And in this case, it cannot be, right? If we use the equal to sign, then we would close that circle up. But essentially, we're going to put an open circle there, just so we know it's a boundary. And at that point, we're looking for numbers that are bigger than 2. Well, 0 is not, 1's not, 3 is, 4 is, but not only that, 3.5 is, and 2.5 is, and 2.75 is, and 2 1/4, and so on and so on. And you'll notice that what happens when you have all of these points is there's an infinity, right? I could literally spend the rest of my lifetime filling in these points. I don't want to. So we're just going to make a line. And I don't want this to go unnoticed. I know we've talked about it this year, but a line is an infinity of closed circles, right? That's all it is. It's a shortcut for saying everything over here is true. Everything over here is an infinity of open circles, of a bunch of falses. And that's how we're going to mark these things. And again, the only reason we're putting one at 2 is we know that that's a boundary. If I remove this, now we're kind of left with this weird sort of like, I don't understand. Like, does that start at 2.1? Does that start at 2.01? Like, I don't know where this whole thing begins. So we're going to go ahead and put that boundary there to separate the correct answers from the incorrect answers. And that's going to keep coming up throughout this chapter. We're going to keep seeing that we will get the opportunity to put boundary points in, and they're going to be really important as this chapter sort of ramps up and gets more difficult as we go. Again, I will say, I think for most of you guys, this chapter will never get truly difficult, but for some of us, it probably will. All right, so let's go and get to 911 now that section 911 now that we've talked a little bit about kind of what it is that we're looking at, and hopefully we can kind of fly through this. So what if the quantities are not equal? Solving linear one variable inequalities, again, big deal. We're talking about lines right now. We're talking about one variable. When we're talking about two variables, we'll look at the coordinate plane. We'll have the x and the y, and it'll be in 2 dimensions. But right now we're just looking in 1 dimension. So it says as a class, create human number line. What would have happened is, I would have given you guys numbers 1 through like 10 or negative 10 to 10, or I don't remember, but it's just like a little number you hold up. So if this one, x is greater than negative 2, x greater than or equal to negative 2. If you were holding the negative 2, the negative 1, the 0, the 1, the 2, the 3, etc., you would stand up right now. If you were holding the negative 3, negative 4, you wouldn't. Here, obviously, anything between negative 1 and 4, inclusive, meaning including negative 1 and 4, we would. Here, only the 3 would stand up. Here, negative 3 would not stand up because it's not equal to negative 4, negative 5, negative 6 would. Here, how many, right? We talked about this already. 2 solutions. 4 would stand up, but so would negative 4. That's a little foreshadowing what's going to happen in this chapter with absolute value. So you really need to be careful with the absolute value. Here, again, this is going to be coming with the absolute value and an or, less than and greater to. A lot coming in this chapter, but here we see 2 things. You could be on this line, you could be 1 or smaller, or you could be on this line, you could be 5 or bigger. So just real quickly, we'll graph what that looks like, right? Here, I always want you to put 0, by the way. Here, it could be 1, or it could be smaller, and it could be 5, or it could be bigger. You'll notice I'm not spending a lot of time making a perfect number line. We have better things to do with our lives. It's fine to just make it sort of ugly. I always want you to put 0 in, because what I get sometimes is kids going like this. And of course 3 is not over there. Maybe negative 3 is over there, but 3 would be over here. So I just want that orientation. Again, on this one, I'm going to put 0 over here. It's not equal to. So I'm going to put an open circle. And anything smaller, again, that's L. It's less than negative 3. Well, the number's less than negative 3 over here. A good number to always check is 0. If 0 is not the boundary point, which in this case it isn't, the boundary is at negative 3, I would say always check 0. Is 0 smaller than negative 3? No, 0 is bigger than negative 3. So 0 is not going to get a closed circle. So everything on this is false. Everything over here is true. Again, the boundaries separate the good answers from the bad answers. So if you know 0 is a bad answer, everything over here must be a bad answer. Everything over here must be a good answer. That's how that's going to work. Again, here, negative 4 and 4, right? We're going to put those, has 2 answers here. Not in between, right? Negative 3, the absolute value of negative 3 is 3. That doesn't equal 4, so we're not going to put that here. Here, what happens if we have both? Well, I'm going to have an open circle here, and the number x, now I'm going to, negative 5 is smaller than x, so x is bigger than negative 5, right? If you're older than your little brother, then your little brother is younger than you. So it sort of works backwards. Here we got a closed circle. And again, I want to point these two out because these are going to become special later. This is sort of like the divergent arrows going in opposite directions. That's the OR shape. These are like a barbell shape, and that's going to be the AND shape. It's bigger than negative 5 and smaller than 0. Here, again, this is really going to become tricky later in the chapter, but essentially what I'm saying is this. This is going to be a OR problem, which we'll talk about later how I know that. So I'm going to get the divergent arrows here. I have a boundary at 2 and at negative 2. It says equal to. So I'm going to go like this. And again, I'm not explaining this right now because this is going to become something we talk about more later in the chapter. But when I get the absolute value, it's either going to be greater or less than greater, less than, right? So I get this shape. And now think about it. If I plug in negative 5, the absolute value of negative 5 is 5. 5 is bigger than 2. Oh, that's true. Negative 5 over here would work. What about 5? If I plug in positive 5, the absolute value of 5 is 5. 5 is greater than 2. That's true. It deserves a closed circle. What about 1? Right? If I plug 1 in, the absolute value of 1 is 1. 1 is not greater than negative 2. You can see I have a open circle there. So again, this is going to be a lot of what we talk about later in the chapter and how we get to that. At that, I don't think I really need to actually erase that. Again, I'm sorry, I'm a work in progress, so your patience is more than appreciated if you actually bother watching these videos. By the way, hello. Hope you guys are doing well. So, based on your observations from 10.1, discuss the following questions to the class. Be sure to justify your responses. Compare the solutions to x is greater than negative 2 with the equation x equals 3. Well, again, we know this has infinite solutions. We know this has one solution. That's one of the big differences, right? What causes that to happen? Well, this is known as an inequality sign, meaning not equal to. I need to get this figured out here. Whereas this is known as, why am I doing this? Oh, that's why. Okay, so I'll do this. And then I know it's probably frustrating for you at home watching this. You're like, you're pushing the wrong button. Anyways, where this is an equal sign and this is an inequality sign. So that's one of the big differences. How many solutions does this inequality have? An infinite amount of solutions. We could spend our whole life marking this, or we can use a arrow. And how are the results in B and G different from the other inequalities? Let's see. G makes that barbell shape, and B also is going to make a barbell shape. We didn't go over that, but it would also make the same shape between negative 1 and positive 4. So that's an AND question as well as this one. All right. So at this point, I would say you should probably pause the video and write the inequalities that go here. I am going to work straight through. So I'm going to get x is greater than or equal to 1. By the way, my preference and most people's preference is to have the variable on the left side. If you're going to put the variable on the right side here, you just have to get it right. X is older than 1, so 1 is younger than x, right? I mean, they both say the same thing. X is bigger than 1, 1 is smaller than x. They're not wrong. I'm not going to mark it wrong. It's just a matter of preference. Here, x is less than negative 1. Here, I have myself a good old-fashioned OR problem. So at this point, I'm just going to write it like this. X is less than negative 3, or x is greater than 2. We'll worry about writing this as an absolute value equation later. Here, again, this is an AND problem. So it is going to look like this. Again, open circle, so I don't put the arrow underneath. Closed circle, so I do put, I'm sorry, the bar underneath, not the arrow underneath. What do I want to discuss here? It's so tough to do this without a class because always I get a question here. Okay, my question I always get is this. Well, I'm going to tell you, you can only write AND questions by connecting them. I'm sorry, you can write and questions either way. You can say x is greater than negative 4 and x is less than or equal to negative 2. Or you can write them in sort of that run just like that. Over here, I always get the question, well, no, Oliver, I wrote it like this too. I connected them all. I put negative 3 is greater than x, and I put that x is greater than or equal to positive 2. So look, I did the same thing, and the problem with that is this. What if you take out the x? Because you're putting in this in the string. So you're saying the whole thing is true. Well, if I go over here and I erase this part of it, now you're saying negative 3 is bigger than or equal to positive 2, which of course is false, right? So an or can only be written, and again, I hope we sort of understand that and maybe kind of pause and rewind that if we need to, but an or can only be written as this or as an absolute value problem, again, which is going to come up later. We'll worry about that later. And can be written either way, because again, negative 4 is, if I go over here and remove this part of it, negative 4 is less than 2. So that's fine. There's no problem with that at all. So just make sure you're careful about those, because that distinction often kind of confuses kids. All right, moving through this. Solutions to linear inequality with your team. Write at least 5 x values that make up the inequality to be true. Again, there's a boundary point here. We're going to talk about solving these equations, but just real quickly, by the way, you should pause the video now and go through this. I'm going to add 5 to both. 2x is greater than or equal to 8. Divide by 2, x is greater than or equal to 4. So my answer looks like this. And you need 5 solutions, anything 4 or bigger, 4, 5, 6, 7, 8, 8.2, 4.999, whatever. All those are great. Again, this is the concept of a boundary point. It marks the true answers from the false answers. And again, sometimes our boundary is true, so we put a closed circle. Sometimes our boundary is false, and we put an open circle. It's just making sure that we understand the two. I'll say it's a little bit disappointing. I'm used to having a quick eraser, and I don't on this program. But beyond that, I'm actually liking this a lot better than my other videos. So I think that's good. All right, so at this point, I will get the rest of this in here. Annotate PDF. No, I don't want. I want to cancel that. I'll discard that. We will get the PDF here. This is the one I want. Okay, so we sort of left off here. Write an inequality that represents the solutions for x. I already did. I forgot what it was, but if you go back in the video a couple seconds, you'll find it. All right, 9.5. Solving linear inequalities. Analyze the process for solving inequality below. Okay, this is a great question. So we need to talk about this as well. So as we go here, let's see. Give myself some white space. And see, okay, good. So how do I solve 3 minus 2x is less than 1? Well, there's a couple ways that I can solve this. So one way is I can add 2x to both sides, and I'm going to get 3 is less than 2x plus 1. I'll subtract 1. I'll get 2 is less than 2x. I'll divide by 2. I get 1 is less than x, or x is greater than 1. Obviously, if 1 is smaller than x, then x is greater than 1. Hopefully, we all agree to that. Well, what if I do this? What if instead I subtract 3 from each side, and I divide by negative 2? At this point, hopefully, you're thinking, I know what's coming. But if you don't, I always get kids doing this. Well, I got 2 completely different answers, right? The thing is, anytime you multiply or divide by a negative, you actually have to go through and change the inequality sign. I did not mean to go back that far. There we go. Okay, so when we look here, I divided by a negative 2, right? Maybe I'll do that instead. When I divided by a -2, this inequality should have flipped and become greater than. As far as explaining why, I'll be honest with you, I don't want to spend the next 5 or 10 minutes explaining why. It's kind of difficult. Usually when I explain it, half the kids in class don't understand what I'm talking about anyways. I guess just it's the rule. Obviously this is true. We can all agree that this is true. In this example, I mean, obviously it ends up false. It just has to do with, like, if a -x equals 5, well, then a positive x must equal -5, right? I mean, you sort of flip those around. It's the same kind of logic that goes with that. So feel free to watch some YouTube videos if you want a real explanation of that. I guarantee you every year I have to watch YouTube videos to figure out new strategies to explain it anyway. So I think that's probably the way to go. Anyways, we'll end the chapter here. 3x plus 1 is less than 7. Again, you should be pausing the video right now, and you should be solving this. Now, I'm dividing, I get 2. So I'm going to go open circle with an arrow to the left. By the way, I want to point one thing out real quickly that I think bears mentioning. That when we go back up and I'm talking about dividing by a negative, I'm talking about the bottom part is a negative. I don't care what the top part is. For example, if I got something that looked like this, 5x is less than -10, and I divided by 5, you can say I'm dividing by a positive. I don't care that this is negative. My answer is going to be x is less than -2. However, if it was -5x is less than 10, now I'm dividing by a negative, and now that sign is going to switch. So hopefully that makes sense between those. Again, feel free to watch other YouTube videos to get a better explanation than I just gave. And I'm going to wrap that up. Have a good one.